This is the Chapter 3 Cumulative Review video number 6. This section is talking about domain and range of the relation, and then we're also going to determine whether the graph represents a function. So if you've recently viewed Review Video 5, we talked about whether relations were functions when they gave us ordered pairs and when they gave us a table. So obviously this time we're looking at graphs. So when you look at a graph and you're trying to find the domain and range, the very first thing you have to do is decide if your data is discrete or if your data is continuous. So I told you guys that discrete is dots. So notice these are individual data points, therefore this graph represents discrete data. Now, the reason that that's important to note is because the way we write our domain and range for discrete data is different than how we write it for continuous data. Okay? So the first thing that I'm going to do is I'm going to look at the points that are on the graph. And I'm going to just list those as ordered pairs. So this point right here is at 1, 2. Okay? So I'm going to write 1, 2. This point right here is at 2, 3. So I'm going to write the ordered pair 2, 3. This point right here is at 3, 4. So I'm going to write that as 3, 4. This point right here is at 4, 5. So I'm going to write that as an ordered pair. And then my last point is at 5, 6. Now the reason that I wrote my data as ordered pairs is because I need those to find my domain and range. So remember, the domain represents or is represented by your x values. So those are the first coordinate of your ordered pair. So I'm going to list those. 1, 2, 3, 4, 5. And I put them in brackets. My range is the set of all your y values. So that is the second number in your ordered pair. So that would be 2, 3, 4, 5, 6. Okay? So notice with discrete data, those are individual data points, I list my domain and range. Okay? So why don't you go ahead, oh wait, let's talk about 30. Is it a function? So remember we talked on the last video that a function would pass the vertical line test. That means if I draw a vertical line at any point on the graph, or if I took my pencil and rolled it across, I don't want it to touch more than one point at the same time. So this would be a function because none of the x values repeat, which means that it passes that vertical line test. Okay, so number 31 is similar to number 30, so why don't you go ahead and pause the video and do that one on your own. Okay, so for this second graph, the first thing I did is I noticed that it was discrete, so I listed my domain. This point has an x value of 1. These 2 points have an x value of 3. And this point has an x value of 6. Remember, your domain are the set of your x values. Then to find the range, these 2 points have a y value of 1. This one has a y value of 2, and that one has a y value of 4. Now notice I circled these 2 points because that is what makes this not a function. If I drew a vertical line right here, it would go through both of those points at the same time, and that's why it's not a function. Okay? Alright, so for number 32, this one is slightly different than the other ones because this would be a continuous function. It's continuous because it's connected with a smooth line or curve. So on a continuous function, the first thing you want to do to find your domain is you want to draw a line on your leftmost point on the graph to your rightmost point. That's going to give you your boundaries. So I know that x has to be between those two values. So notice right here the x value is -2, so that's my lower boundary, and the x value here is +2. So I see that all the x values on this graph fall between -2 and 2. So I write that as -2 is less than or equal to x, which is less than or equal to 2. Now, when you took the first part of your Chapter 3 test a few weeks ago, we talked about the fact that if there is a closed dot or the graph actually touches at those points, then you have the little equal to under your less than sign. But if it was an open circle, then those equal to, that little line under, wouldn't be there. Okay? All right, so let's look at the range. So I always go from bottom to top. So I want to know what my y values would be. So I see that the lowest point on this graph also occurs at -2, and the highest point on this graph occurs at +2. So notice that in a continuous function, you represent your domain and range as an inequality. Now the last part of this is it a function? Well, I can see that if I draw a vertical line, it touches the graph in more than 2 places, so this is not a function. It fails that vertical line test. Okay? So on this next section of your review, it's giving you a verbal model and asking you some questions. So it tells you the function y equals -3x plus 44 represents the amount of money left in your school lunch account y in dollars after x days. The first thing they ask you to do is to identify the independent and dependent variables. So at this point, most of you know that independent is your x and dependent is your y. However, when they ask you to identify, they mean in context. So it tells you right here that x represents your number of days. So your dependent variable, x, represents days. Okay? Your dependent variable, that's your y. Right here, it tells you it's the money left in your account. Okay, so that would be your dependent variable. It's not asking you to say x is independent and y is dependent. It wants you to do it in context of the problem. Okay, so let's go ahead and answer B. It says there are 10 days left in the school year. Find the domain and range of the function. So once again, we're talking about domain and range. So we need to determine if this would be discrete or continuous data. So we are going to assume that this is going down each day. So those are whole number of values. So we are going to call this discrete. So when I write my domain, I know there are 10 days left in the school year. So my domain would be 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. You would have to list the whole number of values from 10 all the way down until there's no days left. That will help me find my range. So to find your range, what you're going to do, there's a couple of ways you could do this. If you're comfortable using your graphing calculator, what you can do is enter this function into the calculator under y equals, which is what I'm going to do. So I have -3x plus 44. I put that in y equals, and I press second table, because I want to see my table of values. Then I simply list the y values that are going with 0, 1, 2, all the way up to 10. For example, 0 is paired with 44. 1 is paired with 41. 2 is paired with 38. 3 is paired with 35. 4 is paired with 32. 5 is paired with 29. 6 is paired with 26. 7 is paired with 23. 8 is paired with 20. 9 is paired with 17. 10 is paired with 14. And that would close out our data. Okay? So if you didn't have a graphing calculator, all you would need to do is substitute in your domain values for x and solve the equation. Because that's all I'm doing. I'm saying, well, 0 times -3 plus 44 would be 44. And then I'm plugging in a 1. 1 times -3 is -3 plus 44 is 41, and so on and so forth. Okay? Notice I listed those because it's discrete data. Okay, so we are finally into Chapter 3. This was actually 3.1. So if you needed some extra support, that's where you could go. You could look at your notes, you could look at the 3.1 videos, you could watch this, or you could come in for tutorials. You guys have a fantastic evening.